Section 112, confirming continuity over an interval. So is the function continuous on the interval? Basically, you're looking for discontinuities. Assume it's continuous, except for where you could find discontinuities. It's kind of the first assumption here. So where would there be a discontinuity on a fraction? You look at the bottom equaling 0. So the discontinuity would be when this equals 0. And when you solve that, you get x equals 9. So 9 is a discontinuity. Is a discontinuity. I'm going to abbreviate that. So is 9 in this interval, though? No, it's outside the interval. So if 9 is the only spot this has a discontinuity, and 9 is not in the interval, then this is continuous. So yes, it is continuous. Next, all right, let's look for discontinuities here. So again, there's a fraction. So when is this denominator ever going to be 0? So let's write that. When is e to the x ever going to be 0? So this one's a little bit tougher because you have to understand how exponents work. Okay, so when would this equal to 0? Well, it's an exponential growth. Exponential growths, if this is a graph right here, exponential of e to the x looks like this. All right, and there's an asymptote right here at the x-axis. So when will it equal 0? Never. So when will this be a discontinuity? When will this ever error out? Never. So is it continuous on this interval? Yes, it is continuous. So is this function right here continuous on this interval? So let's look for discontinuities. Now natural logs have discontinuities when what's inside of a natural log is 0 or negative. So we are looking for where it's continuous will be values that are greater than, oops, said that wrong, where when x plus 3 is greater than 0. That's where it's continuous. The opposite is where it's discontinuous. So if we solve this, all right, x is greater than negative 3. That is where it's continuous. Okay, this is where it's continuous. So discontinuous is going to be values less than or equal to negative 3. So let's look at this. Are these values, if it's continuous, from negative 3 on, is this negative 3 up? Is this greater than negative 3? Yes, it is. So this one is continuous. Yes, it is on that interval. Now, if you had anything less than negative 3 or negative 3 in this interval, it would not be continuous. It would be discontinuous somewhere. Okay, look at this. So you look at the bottom here again, all denominators equaling 0. So when is x squared plus 4 equaling 0? That's our question. So we're going to minus 4 over. So we have x squared equals negative 4. And then if you pause right now and think about it, a squared value would never equal negative 4 if out of logic. But if you don't notice that, well, square root both sides, you get x equals plus or minus the square root of negative 4, which is imaginary. Really, this is x equals plus or minus 2i, which is imaginary, and that is not real. So this has the only values that are discontinuous are imaginary, which don't, so this has no discontinuities. Nothing you plug in here will ever give you a 0 in the denominator. So nothing will mess it up, so this one is always continuous. So this is yet another yes. We have yet to have a no. So these are all yeses so far. Let's see what happens. This one. So cosine 4x. When is this ever discontinuous? Well, for a cosine to be discontinuous is never. Cosine is a continuous graph. It just looks like this. So all 4x is really doing to it is shrinking and stretching it, which doesn't make any, horizontally shrinking and stretching it, which doesn't make any effect to discontinuities. So it doesn't matter what the interval, the whole interval would be continuous. So whatever, this interval is also continuous. So we have continuous on the interval yet again.